knows here because at home, I think Acellent has been present every time we've made that SHM-in-Action show here. And the person to present is, I think it's Jeff Bergman, and you are assisted by a few other people.
Yeah. All right. Welcome to Acellent's 2013 SHM-in-Action live demo. So what we're going to start you off with is a simple question. I think you all know the answer to it, and that is, what are the advantages we derive from structural health monitoring? To give you just a few, there's increased efficiency, increased objectivity, and decreased downtime in systems. So we, as a community, we go out and we go to industries and we say, we can apply these to your industry and give you better results. But often when we do this, we do static demos for them, and it leads to the question, will this work in the dynamic and harsh conditions that we see in reality? At Acellent, our answer to this question is yes, it absolutely will. And we've proven this. And for example, with onboard systems working on aircraft, helicopters, as well as systems working in other industries where we've demonstrated this technology. A great example of this is the recent pairing of Acellent technologies with Metso, a leading manufacturer of paper rolling equipment. Metso came to us needing a robust sensor layer that could provide active pressure mapping of their paper manufacturing equipment so that they could measure the amount of force they're placing on the paper and be able to adjust it very accurately. The idea behind this is that they could increase efficiency and control their system more accurately. So we designed for them a very, very special layer. This is a passive layer for the purpose. We're going to bring it out here. It's 12 meters long. It's very robust. It's designed to work in a very dynamic, very high pressure, very high temperature, and very wet environment that is paper manufacturing. And more importantly, it's designed to work at the very high speeds required for paper manufacturing. So for instance, this layer works even if the equipment is rotating as fast as 50 miles per hour. So that's an example of what we've done in the industrial field. And now we're going to show you a live demo of how we can take the same type of technology and apply it to active damage detection on a rotating device. So what you're going to see in the background is we're going to show you a 3D model of our device up front, and we're going to create damage on it or simulate damage on it and actively map that to our device model while the device is rotating. So if my equipment operator here will turn the machine on, and you'll hear, it doesn't sound as loud in this auditorium, but when we're working with this, it's very noisy, it's not quite balanced, there's a lot of dynamics going on here. And so what we're going to do is, the person operating the equipment is going to knock a temporarily installed patch off of the system. So if we can knock that off now. So we've knocked the patch off, and now what we're doing is we're using Acellent's proprietary custom sensor layer technology. This technology is installed directly on the pipe. It's a piezoelectric based sensor that's being sensed by our custom hardware in the back. If we could get a view of this. This is brand new hardware from Acellent. It's lightweight, it's compact, it's small. It provides 32 channels of active sensing combined with communication and data storage. And we can take this and use it for our damage detection, and then we can transmit that information back, in this case using a wireless connection to our inspector who is operating over here. And we can use that to monitor the damage. And the advantage to this then is that we can have the inspector anywhere with any type of equipment. In this case we're using a laptop because it will give us better visuals. But in any situation you could have a PC, you could have a tablet, you could have any type of connection you needed, and you could have him anywhere in the facility doing this operation. So if you heard that noise in the background, that means that our damage detection is done. If we can get the camera to come around up front, or here we go, bring it up front, you can see the result, which is, get a better visual of that. You can see the model that we showed you is going to have damage mapped to it. There it goes. And you can see there's a damage spot way up on there, red, a very dark red spot right where we took the patch off. Did that show up very well? There we go. We got it there. So we could actually do this, and we did this because because we have very good environmental compensation in our systems. So we can compensate for temperature changes, but we can also compensate for the dynamic changes we have in such a rotating system. So for example, actually the baseline data we used as our reference for this damage detection was actually taken while the system was turned off and sitting still. And then we did the damage detection right now when it was turned on. So we can do this and we can get good results doing it. And it's a result of our very good ability to compensate for the dynamics and the harsh environments that we see in these systems. So that's what we wanted to show you today, how we can do this. We can do this for active systems, apply it to new industries like industrial equipment, and do new SHM technology in a variety of industries. Thank you very much, and enjoy the rest of the show.